negative 1 if there's not a number in front. So let's go over the review sheet today. So the first thing we're looking at is problems 1 through 4. Are there any questions on problems 1 through 4? 1 through 4 that we want to look at? Questions on 1 through 4? 1. Now there are two numbers and a variable with 1. Negative 256 is less than x is less than or equal to 100. So we have two endpoints. And our two endpoints are negative 256 and 100. And we'll list those two endpoints. Now we'll either have parentheses or brackets. Parentheses are not included. Brackets are included. Brackets are for when it's equal to. Parentheses is when it's not. So if we look at 100, it has the equal to. So it's going to be a bracket. Now the 256, the sign does not have one, so it would be a parentheses, and that would be it. Any other questions on number 1? Any other questions on 2 through 4? Question on 2, 3, or 4? Questions on 5 through 8? One of these that we want to see done. We can look at number 6. Now 6 only has a variable in one number, which means it's going to go to infinity or negative infinity. And the only endpoint that it gave us is 4. Now the one that we choose, infinity or negative infinity, is going to be dependent on if x is bigger or smaller than it. And in our case here, we're saying x is greater than 4. So x is going to be bigger. So we'll use positive infinity. Now since it tells us it is not equal to 4, we would use a parenthesis. And we can never get to infinity or negative infinity, so it will also be a parenthesis. And that is it. Any other questions on 1 through 8? Any question on how we do any of those there? If there's no other questions on 1 through 8, let's go to the next one. As I said previously, 9 through 14 are not going to be on the test, so we don't have to worry about those. I did do a video last night and uploaded it that has all the problems and only 2 from this section. So if you want to go back and look at those, you can. They're not going to be tested items. They are bonus questions. So if you want to go back and look at those, you can. But we're not going to specifically go over these here. Questions on 15 or 16? Questions on problems 15 and 16? Okay. Either one. Which one do you want to look at? 15. Now we can do this by hand or in the calculator. Either works. But you don't have to do it by hand on the test. You can do it in the calculator. Now if we did this in the calculator, we do need to write it as an augmented matrix. And the first thing we need for it to be an augmented matrix are the variables in the correct order, x, y, and then z. Now for us here, they are already in that setup. They're already in the setup we need them. So we can write it out. So for x, it would be -1. For y, it would be -5. Z is -5, and it's equal to 2. Then we do the next row. 4 for x, -5 for y, 4 for z, and then 19. And then the last row, we'd have 1 for x. Ooh-wee. 5 for y. Ooh-wee. Thank you. -1 and -20. I think that was sneezes coming on for about the past 5 minutes. Questions on how we set this up? And this will be a 3 by 4. The only time we plug in zeros is if it is missing. Because if the variable is not there at all, then we would plug in a 0 for it. But if it does show up, it might be 1 or -1 if a number is not in front of it. Now to plug it into the calculator, clear all that out. We'll go second matrix, and we have to plug the first matrix in. Now it is a 3 by 4, and we get this here. Now at this point here, we plug in the augmented matrix. -1, -5, -5.
It's now time to release the students who are going to the cross-country meet today. It's now time for the students who are going to the cross-country meet today.
4, -5, 4, 19. And the last one, 1, 5, -1, -20. And we get this here. Questions on how we type this in. Now from here, we're going to go second quit. Second matrix, over to math. And then we need to find REF. Then we need to recall the matrix we typed it in. So we'll do second matrix A. And then hit enter one more time. And that there is going to be our answer. So the numbers going top to bottom, -2, -3, 3 are our answers. So the answer -2, -3, 3 is the solution for this here. Questions on any of this here? Question on how we type these in. Now there will be 2 of these on the test, and neither one of them is going to be a no solution or infinitely many. You will get an answer for both of these here. Questions on either one of these here? We good with 15? 16 will be done in the exact same way. Yes.
So number 9, I wrote it as x 87. X is greater than equal to. So can I got it wrong? So how do I know? Yeah, how do I know how to put that less than?
Because x is going to be between them. So x is going to be between the 2 values. Right, so we don't have to shade in between. Yeah, we would shade in between if we drew it on a number line. So we have the 2 circles, we would shade the middle and include that there. Yeah, to write it in set builder, we would need to turn it into an inequality and then have our brace.
So is it always going to be between x like that?
If yeah, for the most part, with this here, yes, because it's between those 2. Yes. You're welcome. Any other questions on 16, 15, 16, 17, or 18? 17 is no solution, and 18, I believe, is infinitely many. So we have those there. 19 and 20, are there questions, or which one of these that we want to see worked? 20. Now, when we look at 20, again, we're wanting to write the augmented matrix, so we want our bracket. Now, if we notice in each of the equations, there is at least one of them with x, one of them with y, and one of them with z, and some have all 3. So we will need all 3 variables. Now, the first equation I want to look at is the middle one. Because if we notice the middle, x is not first, y is. So there's 2 ways we can go about doing this. One is we could rewrite the equation, or 2, well, what is x's value? So we know it should go first, and then the next value would be what? And then 4, and lastly. So we can fill it back in with it adjusted. We don't have to write it back out. We can, if it does help, to rewrite it back as negative 7x plus y plus 4z equals 15 with it switched, or we can plug it in the correct order. Either way works. Now, any questions on the middle row? Let's look at the first row. Well, the value of x is what?
Or 6.
6, because we have 6 for x. Now, we do not have a y, so it's 0. Because y was not in the equation at all, it's filled in as 0. If the variable does show up, but there's not a number in front of it, it's understood to be 1. It could be negative 1 if it has a minus sign in front of it. The z is 4, and it's equal to 2. And the last row is going to be negative 1. And what are the dimensions for this? 3 by 4. 3 rows, 4 columns. And we'll have to use an x for the by. We don't want to use the dot because we're not necessarily saying multiplication. We're talking about the dimensions 3 by 4. Any other questions on 19 or 20? Questions on 21 or 22? We feel good with 21 and 22. Questions on 23 or 24? 24. All right, so we can go on and do it out. So the first row would be 6, 0 for y, negative 1, 2. The next one would be 9 for x, 1 for y, negative 1 for z, and 14. And the last one would be 0 for x because we don't have an x, 1 for y, 9 for z, and 3. And it is a 3 by. Yeah, no, it's just offset. Any other questions on 19 through 24? Questions on 25 through 29? One of these that we want to look at. Okay. We can look at 26. Translation right 4 and up 3. And whenever we do these, we always do them in order. Now, 2 of the ones on the test will only have 1. 2 of them will have 2 like this here. And for the ones that have more than 1, we just do them in the order that they appear. So the first one's right 4. Now, again, I would refer back to the translation list that I had y'all write down yesterday. I have it still up on the whiteboard to know which one and how we apply this. So right 4 is our horizontal translation, our f of x minus h. Now the h value in our case is 4. It's going to be positive 4 that we plug in because we're moving to the right. If it had been to the left, we would have plugged it in as negative 4. And again, we're only using this notation to help us see the movement. And the f is just naming the function. It's telling us that we're referring to this function here. Now, when we look at this inside the parentheses, we don't have x anymore. We have x minus 4, which means this x in the function f of x is being replaced with x minus 4. Everything else stays the same. We're just replacing that x, this x right here, with this whole statement, which means we still have the absolute value bar. We still have our first 2. But then we have parentheses x minus 4 minus 1. Because the only thing we switched out was the x for the x minus 4. Now at this point here, we do need to simplify a little bit. So we need to distribute the 2. 2 times x is 2 times negative 4 is negative minus 1. At this point here, we can combine like terms. Negative 8 minus 1 is negative 9. So when we translated this function 4 units to the right, it became 2x minus 9. Now I'm going to use g of x as a way to just name this new function to know which one we're talking about next. Questions on this so far? So we finished translating it 4 units to the right. Now we need to go up 3. Now our up and down was our f of x plus k, or in this case, it's going to be g of x plus k. We use g of x to refer to that function we just applied the horizontal translation to. Now in our case, g of x is still g of x, so we just replace it with its function when we do that. Before we do that, we need to put in the value of k. Well, what is the value of k? It is 3. Would it be positive or negative? As we're going up. So plus 3. Okay, because I got ahead of myself a minute ago. And just like before, it's still g of x. We're not doing anything to anything inside the parentheses. It's still x, still g of x. So that means this is still the absolute value of 2x minus 9. It's not changing. We didn't change anything to that function with it, the x. Now, because there's nothing in front of the parentheses, we can go on and remove them, which tells us that we have the absolute value of 2x minus 9 and then plus 3. Do we have any like terms? Nothing that we can do with, because we can't move the 3 inside the absolute value. So this here is the final answer. Now, if we want to give it a name, we can call it h of x. But the main thing I'm looking at is the actual equation itself. The absolute value of 2x minus 9 plus 3. Questions on this here? Questions on 23, 24, or 25, 26, or 27? Pretty good with these here. Questions on 28, 29, 30, or 31? Now let's just look at 28 and 29. Questions on either of those there? Questions on how to do those, or want to see one of those worked? Which one? 29. Translation 7 left and reflected across the x-axis. Again, we do these in order. So the first thing we're going to do is a translation of 7 units left. So translation to our left and right is our f of x minus h. Now in our case, our h value is indeed 7, but would it be positive or negative? Left is negative. Yes, but do we ever leave a negative and a minus next to each other? No. So it's going to turn it plus. So we have x plus 7. Now again, we had something similar in the last one. I've replaced the x with x plus 7. So that means every x in the function is going to be replaced with x plus 7. The rest of the function stays the same. We still have the 5 when we plug it in. But instead of x, we now have the quantity x plus 7 minus 1. Now at this point here, we can distribute the 5. 5 times x is 5 times 7 is plus 35 minus 1. 35 minus 1 is plus 34. So this would be our g of x. Questions on this so far? Now the next part is going to be the reflection across the x-axis. And if we refer back to this for reflection across the x-axis, it'd be our negative f of x, but here we're plugging it to g of x because g of x, again, just another way to name which function we're talking about. So we're applying a negative to it. Now, because we didn't do anything to g of x, we can go on and plug it in. And we don't have to add any values. The negative's already taken care of. Any questions on how we got to this point? Any questions on any of this so far? So now to simplify, we distribute the negative. Our negative times 5x is going to be negative 5x. Our negative times 34 is negative 34. And this here is our answer. If we really want to give it a name, we could call it h of x, but again, the main thing I'm looking for is the function itself, not so much what we're calling it. Questions on 29? Any questions on any of this here? Any questions on anything we've done so far? Good? No questions? Sure? Okay. Questions on 30 or 31? Questions on 30 or 31? Because again, even if we have more than one, we're just doing the same process again and again. We do it in the order that they show up. Now the first one's a horizontal translation of 4 units left. So we're moving left or right. So again, we have f of x minus h. Now unlike reflections, we have to actually plug a value in. And the value for h is 4, but it would be negative, negative, and negative make a plus. So we get x plus 4. Because again, inside the parentheses, opposite of what we think, because when we think left, we don't think of x plus 4, we think x minus 4. Any questions on this here? Now, we don't have f of x anymore, we have f of x plus 4, which means every x in the function must be replaced with x plus 4. So what we'll have is we still have the 2, we still have the absolute value bar, but instead of x, we have x plus 4 minus 3. Now we can drop the parentheses because there's nothing in front of them to multiply through, so we still have x plus 4. But at this point here, our plus 4 minus 3 becomes plus 1. Now to kind of help us out so we're not confusing our original function f of x and this one here, I'm going to call it g of x. Any question on the first transformation? Now we'll move to the second one, vertical shrink of 1/3. Vertical stretch or shrink is our a f of x. In this case, it will just say a g of x, because again, f of x, g of x, a of x, b of x, c of x, any of these are just another way to name the function. Now our value of a is 1/3. So we have 1/3 times b of x. Now because we still have g of x, we don't have g of x plus 4, we just have x inside the parentheses, we can replace g of x with its function. 2, absolute value of x plus 1. Now at this point here, we're going to distribute the 1/3. There's only one thing to multiply it by, which is the 2. And 1/3 times 2 is 2/3. Questions on this here? Questions on any of this here so far? Now we could call this h of x to give it a name, but we've now done the vertical shrink of 1/3. And the last part is horizontal stretch of 4. Now this is our f of ax. A's inside the parentheses this time. But again, there is a note next to horizontal stretch or shrink. We've got to flip it. So instead of 4, it is now 1/4. Because with horizontal stretch and shrink, we've got to flip the value. Horizontal stretch or shrink is the only one we do this with. Because again, it's following kind of that opposite of what we think. Because if it's a horizontal stretch, the value looks like a shrink. And if it's a horizontal shrink, well, the value we plug in is going to look like a stretch. Now, again, just like with our left-right, we don't have x anymore inside the parentheses. We've got 1/4 x, which means every x in the function h of x has to be switched out for 1/4 x. So I have 1/4 x plus 1. Well, really, that's just going to simplify to 2/3 times the absolute value of 1/4 x plus 1. And that's it. And then we can call it whatever we want. We can call it a of x. We can call it y of x. We can call it z of x. We can call it q of x. We can call it whatever we want, but that is the final answer. Questions on this here? We good with these here so far? Yes? Are we ready for the next one? Because this one here is the exact same thing, just doing the same process. I'm going to leave that one for y'all, so if you haven't worked on those yet, you get a chance to look at it. I do have the video up of it actually being done, so if you do have questions, you can come back to it. The multiple more than 2 are the bonus. I did one of those for the bonus. Now the numbers differ on this part here, because I know yours say 32 instead of 30 and 33 instead of 31, but are there questions on these two here?
So what if we just multiply 1/4 by 16?
Yes.
And then 1/4 by 4, and then...
Yeah, we do it to each. So 1/4 times 16 is 4. 1/4 times 24 is 6. 1/4 times 30 is, well, there's two answers. One of them we could say is 15/2, and 1/4 times 9 is 9/4. Because we could have said 7.5 or 2.25. Either one works. That is the answer. But if you turn one of them into a decimal, the other ones need to be in decimal form also. But if you put one of them as a fraction, you need the other one as a fraction. Now, 4 and 6 are fine either way because they do not have a fraction part of it that is not already reduced. So we have this here. Questions on this problem here? Questions on 33. $31 on the board or 33 on your paper? We good with addition, subtraction?
2 minus 1.
So 2 minus 1, then what? Mm-hmm. 8, 7, 2. Okay. 2 minus 1 is 7 minus 4 is 3. 9 minus 16 is -7. 8 minus 27 is -19. Now we're going to do a similar thing, but this time we're going to add. 1 plus 3 is. 3 plus 8 is. Then, and, yeah. Scalar multiplication, we multiply. But here we don't have to. Questions on the next two? Questions on these here?
When we substitute that 2 into the first and then the 4 into the other one,
Yes.
then would be minus the 20 second one that we had.
Yes. Because if we distribute the 2, 2 times 3 is 6, 2 times 1 is 2, 2 times 4 is 8. 8 times 4 is, what's 8 times 2? 16. Times it by 2 again. Because that's a way you can multiply. So 4 times 6, well, 6 times 2 is 12. 12 times 2 is 4 times 7. Yes, you could bring the negative, you can multiply each one of them by -4, but if you do that, you have to add them instead. Just leave the negative out and then subtract what you get. We only distributed the 4. Because if we did distribute the negative, all these would be negative, but we would add. Because we distribute the negative through. Well, the negative, if we do -4, is now inside instead of outside, because 6, because it'd be -26. 2 plus -24 is -22, and 8 plus -28 is -20. Because if we'd have just left the negative out, it would just have been subtraction, but we get the same thing. We can't multiply by the -4 and subtract both, because that undoes itself. And the last thing, -26 plus 3 is -23. -22 plus 3 is negative. And -20 plus 3 is negative. And that's it. Now the other way we could have done this in the calculator is I could plug this in as A, this is B, and this is C, and then when we input it, it has 2A minus 4B plus C, and told the calculator to do it for us. So that is possible too. Questions on this here? How about number 33 up here, 35 on your paper? What would it be? We are going to subtract. There's or not possible, because to add or subtract, the dimensions have to be the same. I may put one of those on the test, because that's not so much a calculation deal, it's just looking at it. This is a 3 by 3, this is a 3 by 2. They're not the same, so it doesn't work. Questions on those there? So one of those, 33, 35 on your paper, might show up. There will not be a no solution on the 3-variable system of equation. Okay? Again, I'm going to say that again. There's not going to be any no solution on a 3-variable system of equation. For those who had me last year, I'm going to say it again. I do not do that because your first thought is not it's no solution. It's probably I did something wrong, so I don't put them there. But this, it's more just look at it, 3 by 3, 3 by 2. They don't match. It's not possible. We can see from the beginning we don't have to actually do any work into it. Questions on 34?
So it's the same as the other one, we just bring that thing down.
Yeah. because you can multiply -6 by it, but then you would add your results instead of subtracting.
And we make that 2 positive. So it'd be
Yeah,
9.
right. So 7, well, -6 times -2. If we did the negative, would be 12, and then we'd add
Yeah.
to get 19. Yeah. Or you can do it in the calculator as 5 and
I don't know why I was thinking 7 minus -2. That's weird.
fractions, alpha, y equals, enter, green button all the way up at the top, enter. If you do have questions on how to do that or some of the other stuff on the test, I will tell you how to do it. I can answer those. But any questions up to this point before we look at 38, 39, and 40? Questions on 38 or 39, one of those that we want to look at.
Let's go over that again. 'Cause I don't
Okay,
think I remember.
38 or 39.
39.
Okay. Now with these here, especially on the test, it's going to ask for two things. One is the slope, and the other is the equation of the line. So to find slope, y2 minus y1 over x2 minus x1. What is one of our y values?
Oh, that,
And its corresponding x value is? What is the other y value?
40.
And its y value, or x value is 15. I think it's kind of ironic that 40 is technically one of the y values, but it's also one of the x values. Now at this point here, we could plug it in. Now, for the most part, you can do this in a graphing calculator. I would do this in the other one and hit enter. Because I don't know about y'all, I can plug some stuff like this in a little bit easier in the yellow calculator than the graphing. Because to plug this into the graphing calculator, we have to go alpha y equals enter to get the fraction. 90 minus 40 over 40 minus 15. So either works. And we get, if we did this by hand, would be 15 or 50 over 25, which is indeed 2. So on the test, we have half the answer. We need to find the slope. But realistically, to find the equation, you need the slope anyways. Y minus y1 is equal to m times x minus x1. Well, we can plug in our slope as 2. And what's our point? You just pick one. 15 for x, 40 for y. Now we just need to get y by itself. And the first thing we can do is to multiply by 2. Well, 2 times x is 2x. 2 times negative 15 is negative 30. And the last thing we'll need to do is add 40 to both sides, telling us y is equal to 2x plus 10. And that's it. Questions on this here? We good with this one here? Let's go on and do this one here. Now again, our slope is our y2 minus y1 over x2 minus x1. Now 565 is one of our points. It works out that the other is 0. 65, I will have both points labeled on the test. Now our two y values are both, incidentally, 65. the x values are 5 and 0. Yep, 65 minus 65 is 0. 5 minus 0 is 5. But it tells us our slope is 0. Now at this point, we can plug the slope in as 0. Now we need to pick one of the points, 0, 65, or 5, 65. Do you have a preference? I don't pick one. Doesn't matter. Or one of the points. Well, I'll just do 65, 0. Well, we'll still have y minus 65 here. This other side, 0 times anything is, so this whole side becomes 0. At this point, we can add 65 to both sides, telling us y is equal to, and we know this is true because it is a flat line, y equals, and that's it. So your test is tomorrow. All of your homework is due at the end of the day tomorrow. These all get turned in then.